Jumping into Chapter 8. Chapter 8 at the very beginning. The first half is just understanding algebraic equations. The second half we're going to get into inequalities. The first half talks about the algebraic equation. We've talked about algebra being able to use letters inside of our math problems with our numbers, sometimes having a coefficient with our variable, or we're going to have a number multiplied by the letter, or it may be a letter by itself and just be an independent variable. When we talk about the expressions then in this equation, we have one expression over here and another expression over here, and this says it's an equation because it has an equal sign, it's equal to each other. So we're going to have to figure out how we can do the H. I'll give you a reminder of how we do that here in just a moment. But as we move forward, then it's also understanding the terms that are going to be used. And when I say terms, I mean terminology, the vocabulary of math problems. So I'm going to put on Canvas for you to access on the first couple of lessons. It's just a Word document, and you can download it and save it to your computer. Look at it anytime you're doing your math. It gives you the different symbols that we use in math. An addition sign, subtraction sign, multiplication, division. It also gives you some parentheses, and it gives you certain words that are often used in mathematical story problems. So that'll be coming in handy, hopefully, if you decide to use that. So as we're talking about solving for equations then, the first thing, once again, we need to understand is what an equation is. So we've had expressions, some form of math without an answer to it. An equation means that I'm going to have two expressions separated by an equal sign. It's like the idea of terms. Terms are setups. They're separated by addition or subtraction. Well, in an equation, we're going to have the equal sign separating expressions. When I look at the math that is set up, for example here, then in my equation of 18 plus 12 equals 20, then I have an expression of 18 plus 12. I also have an expression of 20. Or in the center, I have 14 is equal to a minus 3. Notice it starts with what the answer is. That's fine. It doesn't matter where the answer is. We're still going to be able to solve our math in the same way. So one expression is the 14. The other expression is the a minus the 3. So on and so forth. Finding out how to solve for it takes us back to recalling something I've taught you before. So on previous videos, I introduced you to the idea of doing the opposite function on the opposite side. We just talked about that yesterday in our math bowl also, figuring out what this letter, this variable, is equal to. So if you can put this back into your head, and hopefully you haven't forgotten it, doing the opposite function on the opposite side, seeing these easier problems at the first couple of lessons will make going into the harder lessons here in a few days easier for you to understand. So we start out with the scenario that they give us. In 2009-2010 season, talking about the women's basketball team for Duke University. They lost 5 of their 29 games. The equation W plus 5 is equal to 29 can be used to find the team's number of wins, which is what the W stands for. Determine whether the W equals 14 or the W is equal to 24 is a solution. Tell what the solution means. So here's what we're doing on this lesson, and it's really simple. Your answer is either going to be it is or it is not. We're not solving for what the letter is equal to. They're going to tell us, here's the equation, plug in what the variable stands for into the math, and tell, does it hold true for the equal sign or does it not hold true? It is or it is not. So when we look at this one, and we're going to start with the 14. Does the 14 give me a solution? It is a solution or it is not a solution. But I want to take what they tell me the variable is equal to, and I'm simply going to plug it into the equation that I'm provided with. I'm provided with W plus 5 equals 29. I plug the 14 in for the W. That gives me, on this side, the expression of 14 plus 5. On the other side, the expression is what it should be equal to. When I add those together, 14 plus 5, it tells me, well, that's 19. Those are not equal to one another. So another thing to recall is that on one of the previous videos last week, I showed you that equal sign with the slash, we're not going to see it in our book as well. It just simply means it's not equal to. 19 is not equal to 29, that should be pretty obvious. So we know that our answer is either it's going to be not equal, it's not equivalent, or it's simply not a solution, depending on how the wording is set up in our problems. Step 2 then, remember they gave us two numbers to check for our W. Step 2 is using the 24 and plugging it in to the equation. W plus 5 equals 29 once again, this time using the 24 for the variable. So 24 plus 5 gives me my 29. 29 is equal to 29? Well, yes it is. They're the same number. So I know they are equal, so I know my W is indeed 24, and therefore there were 24 games. So that would be an answer of it is a solution. On example 1, it says, determine whether the given value of the variable is a solution for the equation. It gives me the equation and then it tells me to plug in the 3.6. So I have the equation of x minus 7/10 is equal to 4 3/10. And then I plug in the 3 6/10 for the x. When I do the subtraction, I line them up, I subtract them, I get 2.9. So then the circle is it going to be equal or is it not going to be equal? Well, they're not the same numbers. So we get that slashed out equal sign, which just means that it's not equal. So the equation is not true when the x is equal to 3.6. It's not a solution for the problem that we were given. On this one, they give us a fraction instead. Well, fraction touching a variable means the same thing as a whole number touching a variable. The 1/3 is still the coefficient to the variable of a. So I know it's multiplication, and I know I'm going to plug in where the a is, the fraction of 3/4. I have 1/3 times 3/4, so when I look at that, one of the first things I should notice, since we've been multiplying fractions since lesson 1 and lesson 2, is I can cross-reduce my 3's, which makes my life a lot easier. If I cross-reduce those 3's, then I'm left with 1 times 1, which is 1, and 1 times 4, which is 4. So I get my new fraction of 1/4, and when I compare them, I see, yes, indeed, they are equal. So the equation is true when a is equal to 3/4. So a is equal to 3/4 is a solution. So once again, on the assignment, we're going to be finding out, is it a solution or is it not a solution? Does it work or does it not? On example 2, it says, the 6th grade class president serves a term of 8 months. Janice has already served 5 months of her term as class president. The equation of m plus 5 equals 8 can be used to determine the number of months, which is what m stands for, that Janice has left. Use mental math to find the solution of the equation. So what they're saying is you should be able to look at this problem and figure out what the answer is already. However, because showing your work is required, we then have to prove that our mental math is correct. So if I think about what 5 plus is equal to 8, then I should know that it is going to be 3. But then I have to prove it. So if I plug what I believe 3 is equal into, I'm making a hypothesis, I'm going to test it, and then I'm going to analyze if it was true and draw a conclusion. So m is equal to 3. I plug in 3 for my m. 3 plus 5 equals what? 3 plus 5 does equal 8, which they are equal. So I know the m is equal to 3. And m equal to 3 is the solution for the equation. Therefore, there are 3 months in Janice's term that remain. Should be pretty easy, I hope. Should be a very basic lesson. So we're going to jump into the practice problems and look at first what they ask us to do. Determine whether the given value of the variable is a solution of the equation. So it is a solution or it is not a solution. But the only way I can have an answer of is or is not is by showing the work. Have to show the work to get the credit. So when I start looking at it and I see the equation they give me, x plus 12 is equal to 29, where x is equal to 7, I simply plug it in. I put 7 plus 12 equals 29, and then I do the math that is there. 7 plus 12 is 19. And when I look at 19 compared to 29, I know they are not equal to one another, so therefore this is not a solution. If you want the shortcut to writing your answer, then the shortcut is not a solution. If you simply put not as an answer, I'm going to count it wrong. It's not what? Is it not an elephant? Is it not a tomato? Or is it not a solution? I need you to be specific. When I take this equation, n minus 13 is equal to 2, I'm looking at plugging n equals 15 into the equation. So my first step is always to write the equation with the substitution of the number for the variable that's given. So I'm going to put 15 minus 13 equals 2. That's the first step of showing my work. Then I solve for the information that I have now. 15 minus 13 gives me what? Gives me 2, right? And so therefore I know I have 2 equals 2, and therefore my answer is not 2, it is a solution. That's my answer to my question. On number 3, once again I have a fraction with a variable. It's still a coefficient. I still know that it's multiplication. I'm finding 1/2 c is equal to 14 as my equation, and I'm going to substitute 28 in where the c is. So when I start looking at that, if I remember how I multiplied by 1/2 to get the area of a triangle, and then we said, well, that's really just dividing by 2. I could multiply across and end up with 28 over 2, which tells me to divide. Or if I know every time that I'm multiplying by 1/2, it's just simply division, I can skip that one step and just set up my division problem of 28 divided by 2. 28 divided by 2 is indeed 14, which they tell me it's equal to, so I know that this is a solution. And it is a solution is my answer, and then my second point comes from showing the work. So now my new equation is, for number 4, m plus 2 5/10 is equal to 4 6/10. I'm going to substitute in for m 2 9/10. So I write the new problem with the substitution method in. So I put the 2 9/10 plus whatever was left. 2 5/10 equals 4 6/10. When I add or subtract decimals, I line up my decimals and bring it down. So I line up my decimals and bring it down, and then I do my straightforward addition. 9 and 5 is 14. Carry my 1. 2, 2, and 1 gives me 5. It says that 5 and 4/10 is equal to 4 6/10. That is not a solution. It does not match. On number 5, d minus 8 7/10 is equal to 6. I know I'm going to substitute for d, 14 7/10. It's going to go in front. I'm going to substitute it in and rewrite my math problem. So I'm going to have, for my d, 14.7 or 14 7/10 minus 8.7, 8 7/10 is equal to 6. Just like I stacked up my decimals and then dropped it, I stacked these decimals and dropped them. 14.7, 8.7, it's subtraction, bring down my decimal, I get 6.0. And we know if I have a number with a decimal at the end of zeros, I just drop those off. So it's just a 6. Is 6 equal to the 6 they told me to start with? It is. So I know this is a solution. That's my answer. This is my second point by showing my work. On number 6, I'm given the equation k minus 3/5 equals 1/10, where I'm going to substitute in for k 7/10. This takes us into reviewing a little bit on how we add and subtract decimals, or not decimals, but fractions. Because when I set that up and I substitute the 7/10 in, I see that I don't have a common denominator. So I have to remember how to do that. I go through my questions mentally. Can I subtract fractions? I can. Do I have the same denominator? I don't. Does my smaller denominator go into my larger denominator evenly? Well, it does. 5 goes into 10. So that tells me I'm just going to leave this first one, and then I'm going to change my second fraction to where it has a denominator of 10. And whatever I do to the 5 to get the 10, I have to do the same to the numerator. So I'm making an equivalent fraction. It's worth the same value, but it's using different digits in it. So I multiply the 5 by 2 to get my 10, and then I multiply my 3 by 2 to get my 6. So now I'm going to have 7/10 minus 6/10. That's going to be equal to 1/10. Now I can subtract. I have the same denominator, so I keep it. My numerator, 7 minus 6, is 1. 1/10 is equal to 1/10. So I know this is a solution. Once again, as we work through this math set, it's about finding if it is a solution or not a solution, and the other half of it is showing your work to prove it. Number 7, I have 17 9/10 plus v is equal to 35 8/10. They're telling me to substitute for v, my variable, 17.9. It's the same number I start with, but that doesn't matter. That doesn't change my math. I'm just going to substitute it in, rewrite my math problem, and then do the math. 17.9 plus is what I started with. I substitute in for the v, 17.9, and that tells me that it should equal 35.8. I stack them up according to decimals. I bring my decimal down, and then I do the math. And once I do the math, I find out I get 35.8. They tell me it should be equal to 35.8, so I know that is a solution. So that takes me to 8 and 9. I want you to do 8 and 9 on your own. Pause the video, do the work, come back and unpause, check your answers, and see how you did. Alright, so hopefully now you have 2 answers on your paper, and we can see how we did. The whole point of this is so that you truly understand what we're doing, and you're able to be successful on your assignment. And then if you're not, then you can see the work that I've provided for you to check your answers and see where your step was messed up. So let's look at number 8. On number 8, you should have substituted in for the c, which is at the beginning of the equation, the number 32. That left you with adding 32 and 35, which gives you 67 once you stack and add. And 67 is not equal to the 57 they told you to expect. So you should have the answer of not a solution. On number 9 then, when we work it, I'm substituting in with the 12. I put the 12 in to the equation, and I end up with 18 equals 2/3 times 12. Well, multiplication, I'm going to set my 12 up over 1. That gives me cross-reducing that I can do, because my 3 goes into 3 once, and my 3 goes into 12 4 times. And then I'm left with multiplying across. 2 times 4 is 8, and 1 times 1 is 1, so I just left it as 8. And 18 is not equal to 8, so it's not a solution. So hopefully you were able to follow along and get to the same answers. Now we're going to look at 10 and 11, and what I need you to understand is this is worth multiple points. There's going to be worth 4 points on this answer. It's either going to be yes or it's going to be no. So when I look at it, in the equation of t plus 2.5 equals 7, determine whether t can be equal to, and here's my 3 problems I'm going to do. I'm going to substitute 4.5 in, then I'm going to do a second problem, substituting 5 in, then I'm going to do a third problem and substitute 5.5 in. I have to check each one, even if my first answer is yes, this one works. So I plug in my 4.5, I add the side together to see if I get this answer. Well, 4 5/10 plus 2 5/10, I stack them according to decimals, bring my decimal down. When I add those together, 5 and 5 is 0, carry my 1, 4, 2, and 1 is 7. It is 7. That tells me it's going to be 7. So if it needs to be equal to 7, then I know that 4.5 does indeed work. That one is a solution. Now I got to check my other 2. So 1 point there, and I got what my answer was, which is 4.5. Now I got to get my other 2 points. I plug in for 5. I'm substituting where they tell me that t is now equal to 5. I end up with 5 plus 2.5. They tell me it should be equal to 7.5. When I stack them, I don't have a decimal there, but I put 1 behind my whole number so it doesn't mess up my work. So I put my decimal there and I bring it down. I'm left with just adding 5 by itself, and then 5 and 2 is 7. 7.5 does not equal 7, so t cannot equal 5. And then the last one I checked is 5.5. Well, we know logically that it can't be because 5 took us over what we needed. However, if I have to show my work to get a point, I'm going to show my work to get my point. So 5.5 plus 2.5 is equal to 7. When I add, by stacking my decimals, the 5 and 5/10 and the 4 and 5/10 gives me an answer of 10. And 10 is bigger than the 7. So I know that's not the solution either. So the only one that is a solution was the first one of 4.5. So we're going to look at 11. I want you to do 11, and then I'll walk you through it. I just put some extra space up here. If you run out of space while you're working it, then please find some location that's open in your workbook. So find your 4 or 3 different problems. Find if they are or are not. Choose the correct answer. That'll be 4 points. Pause the video, come back when you are finished. So hopefully you have your 4 different points that you've earned by finding 4 or 3 different answers and then figuring out which one is indeed the solution. So we start by substituting in where I have the equation 9 minus d is equal to 5 1/4, and I substitute in my first fraction that they give me. I end up substituting 4 3/4. Now, I wanted you to try this on your own to see if you remembered how to borrow when I'm subtracting mixed numbers. We haven't done this for quite a while in any of our review and spiral review, but we did this closer to the beginning of the year. But just a reminder how that works. I know at the beginning there, there's a lot of you that want to write 3/4 down as your answer. Okay? The problem is what this is saying is 3/4 taken from nothing. I hold up 0 fingers. I can't take 3/4 from it. The only way I can bring down the 3/4 is if it's on top and I'm taking nothing from it, which is not what I have here. So that means I have to borrow. So borrowing, when it comes to fractions, starts out very similar to borrowing from a tens group, a hundreds group, a thousands group when I'm doing straightforward subtraction. I go to the previous place value, I cross it out, and I lower by 1. So my 9 becomes 8, and how much did I borrow? I borrowed 1 whole, right? Well, that 1 whole has to be translated or transformed into a fraction that I can use. And going back to those subtraction questions, can I subtract fractions? Yes, I have to have a common denominator. So I know the denominator has to match, and if it's worth 1, therefore the numerator has to be the same. So the shortcut when I borrow is just remembering whatever this denominator is, it's the numerator and denominator up here. Then I can subtract. I have the same denominator, so I keep it. 4 minus 3 gives me a numerator of 1. Then I'm left with 8 minus 4, which is 4. Does 4 1/4 give me 5 1/4? No, it does not. So I just cross that out. Now I'm going to substitute the second one. So that's 1 point for doing that work. Now I'm going to look at d is equal to 4. I'm going to plug it into my equation. 9 minus d is 5 1/4. So I know I'm going to plug in 4 where my d is. That gives me 9 minus 4, straightforward subtraction, 2nd and 3rd grade. I'm good to go. Well, it should be 5, so obviously it's not that easy, but 9 minus 4 should be 5. 5 is still not equal to 5 1/4. So I just cross that one out. That should hopefully tell me that the third one is correct, but are they trying to trick me by giving me one that doesn't work either? Well, we plug it in, we find out. So I have 1 point so far, 2 points so far. Now I'm going for point 3. So point 3 would be d, 9 minus the d, and they're telling me to substitute 3 3/4 in for the d. When I do that, I'm back to the same situation I had over here. I cannot take 3/4 from nothing, so I have to borrow from the 9. 9 becomes 8. I'm carrying over. This denominator is 4, so the numerator and denominator is 4. Now I keep my denominator of 4, and I take 4 minus 3, which is going to give me 1. And then 8 minus 3 is 5. They're telling me that that answer is 5 1/4. Should be 5 1/4. I know that that is my solution. So I'm going to say that d is equal to 3 3/4. 1 point, 2 points, 3 points, and now 4. 4 possible points on that question alone. We're going to do some review on these also because some of us were getting tripped up on percentages. So just a reminder on how we do percentages real quick before we finish the video. On this question, it says Melanie has saved $80 so far to buy a lawnmower. This is 20% of the price of the lawnmower. What is the full price of the lawnmower that she wants to buy? So we're going to be doing percentages, but this one I'm also going to set up as a proportion. So proportions are fractions that are equal in value but have different numbers. So let's look at what I'm talking about. I know that 20% is $80. So it says that if I wanted to do the math with my percent, I'd be finding 20% of the price of the lawnmower. But I don't know what the price is. So that of is there. It would be mathematically possible if I knew that price, but since I don't, I can't use it. But I do know that 20% is $80. So I can set that up as an equal sign, and then we can build a proportion with the other information that I know. The other information that I know is that when I have 20%, I'm always talking out of 100%. My percents are always out of 100. So if I have 20 is to 100 as 80 is to what? So a couple different ways I could do it. Now what I did was I looked at it and I said 20% times 4. My 20 times 4 gives me what? Gives me my 80. So if I multiply my numerator by 4, then I have to multiply my denominator by 4. And 100 times 4 is what? It's 400. So I'm going to know that my total price is actually $400. The other way I could do it, if you remember the dividing the loop, I could multiply the loop together. The loop is always, I'm going to go back one. The loop is always the two that are given diagonally. That leaves the lonely number by itself. So I could take the 80 times 100, which would give me 80,000. And then I would divide by the lonely number. So that divided by 20 would also give me an answer of 400. So I know my answer is $400. Another one to look at is the idea of our exponents. A couple of people were getting a little confused on the exponents. I just want to review it real quick with you. A team of scientists is digging for fossils. The amount of soil in cubic feet, that's with an exponent of 3, that they remove is equal to 5 cubed. How many cubic feet of soil do the scientists remove? So all this story problem is asking you is to solve for 5 cubed. And once again, slow down and think before we start writing what that means. Because on the last couple of assignments on these review questions, I had 5 times 3 is 15 on that type of problem. It's not 5 times 3. The exponent always tells me to write the base that many times itself. So if there are 3 of them, I should have a math problem of 5 times 5 times 5. Well, 5 times 5 times 5 gives me 125, and what are we talking about? We're talking about cubic feet of dirt if you want to be specific. So your lesson today, you're going to do page 429, you're going to do 2 through 9. You're going to do page 430, questions 1 through 6. On the front side, it's not about finding out what the variable is equal to, because they tell me what the variable is equal to. I'm substituting that answer into the equation and then saying it is a solution, or I'm saying it's not a solution. Don't put is and not. I'm going to count it wrong. I want you to be specific. I don't know if it is an elephant or if it's not an elephant if all I put is or not. You're going to write is a solution, or you're going to write is not a solution. Those are your options. Understanding how this works is vital to understanding the next couple of lessons when it comes to algebraic expressions and equations, as well as inequalities, which we introduced a couple of weeks ago, and actually probably a couple of months ago now since it was before Christmas, but we're going to get back into it so we have it fresh in our minds. If you have any questions once you've gone through the video and the practice problems and you're still not making sense, that's when you come back to me with your book and we can sit down and you can ask.